Hi everyone, it's Dr. Marks, and we are still talking about descriptive statistics, but we're moving on to part 2 where we talk about measures of dispersion. In the last lecture, we talked about measures of location and central tendency, and these were things that were already familiar to you, right? Mean, median, mode, you understand that. But we also noted some of the limitations. For example, it might be just a little deceptive if we report just a mean. Now, I'm not saying that we're trying to fool anyone, but we could possibly be misleading people, and I'll give you an example in just a moment. We also talked about that some of these could be influenced by outliers, right? A mean is certainly influenced by outliers. If you have one really big observation that you throw in, well, that's going to make your mean move. But the thing that we're going to talk about in this lecture is that a mean or a median or a mode doesn't tell us anything about the spread of the data. And the spread of the data is going to be really important to us as we continue in this class. So that's why we're talking about measures of dispersion. And measures of dispersion are just measures of spread. So when we add our measures of dispersion to our measures of location, well, we get a much better picture of our data. So here's an example. Suppose we give a survey on job satisfaction to our employees, but we have 3 different divisions in our company. So we give this survey to a bunch of people that fall into 3 different divisions, and we get back similar means. Turns out the mean score is 50 out of 100. Well, it doesn't seem like a very good mean score, right? But anyway, it is 50. Well, this is limited information, right? Because it could be that the spread is very different. Look at the graph on the right and you see, sure, we have 3 different divisions. One is in blue, nice and tall. And then you got the red in the middle, which is shorter. And then green, really short, but very wide, right? Do you agree that all 3 of them have the same mean? So it would be a little misleading in this case to just report the mean, because clearly something's going on there, right? We've got one division where the opinions are very, very different. So we need some measures of dispersion to help us characterize this idea that, one distribution is really tall and skinny, but another distribution is short and fat. The most basic measure of dispersion is something you already understand. Range. Range is simply the difference between the largest and the smallest observation in a sample. So I need a minimum and I need a maximum, right? And it's just going to be max minus min. Let's apply this to a very simple data set. Suppose we have data on new clients that we attract each week. So every week we see how many new clients did we get, and we write it down. So in week 1, we got 42 new clients. In week 2, 56. Week 3, 43. You get the idea. If we look at this, eyeball it really quickly, do you agree with me that the min is 42 clients and the max is 56 clients? So 56 minus 42 gives us 14 clients. But our range is also sensitive to outliers, right? Imagine in week 2, instead of 56, it was 96. Do you agree that 96 would probably be an outlier? Every other observation is in the 40s or the 50s, but if I have 96, yeah, that's an outlier, but then that's also going to be our max. So if our max is 96 instead of 56, that changes our range, right? So range is certainly going to be sensitive to outliers. Sometimes it's just better to report min and max specifically as opposed to the range, but you could certainly do both. So standard practice in research would be min and max. You're going to see that in descriptive statistics. Anybody that does research and they're talking about their data set will, for every variable that they're working with, they're going to report a min and a max. It's just standard practice. Another measure of dispersion that you're familiar with is percentiles. Percentiles are commonly reported statistics. For example, you might see something about the 25th percentile of SAT scores for college admissions. Well, that's a percentile. A percentile tells us the observation where 25% of data is below, if we're talking about the 25th percentile, 25% of data is below, and 75% of data is above. Or instead of the 25th percentile, we could report the 50th percentile. So that's going to be where 50% of observations are above and 50% below. But we also have another name for this. So think with me here. If we've got the observation where 50% is above and 50% is below, what would we call that? Well, you'd be right in the middle, right? Because you're at the median, right? So another name for the 50th percentile is the median. A simple percentile itself is not a measure of dispersion. So let me say that again. A simple percentile is not a measure of dispersion. It's a measure of location, right? So it is not dispersion. But what you're going to see is we're going to use it that way because it can be combined to create a measure of dispersion. And that's what we're going to do. But first, we need to understand a simple percentile. So we're going to learn how to compute a percentile. Then we're going to combine them to create a measure of dispersion. So do this first. Let's just go through the simple percentiles. So we're back to our data set of number of new clients. So what if we want the 25th percentile? And I just cut off the weeks because that part of the data set's not important to me. We want the 25th percentile. So we want to find the observation where 25% is below and 75% is above. But keep in mind that this is a bit hard with a small sample. But if we tried to do a really, really big sample here, it'd be hard for me to illustrate. So I'm going to stick with this small number of observations here, but I just want you to appreciate that it makes it a little stranger. All right, better to apply to a big data set. The first thing we have to do is start with ranked data. So ranked means we need to go from smallest to largest, and we have this already, right? I've already ranked it for us. And here's the formula that we're going to use. And this is an important formula. Rank equals the percentile. Well, here we want the 25th percentile. So it'd be 25 divided by 100. That just simply converts it to a decimal, right? Then multiplied by n plus 1. So all we have to do is plug in here. So our percentile, we want the 25th percentile divided by 100. That just gives us 0.25. All we're doing is changing that to a decimal. Multiplied by, we have 10 observations, so our n is 10 plus 1. That's where we get the 11. So if I compute this, I get 2.75. Now, what do we mean by 2.75? We're talking about week 2.75 or the 2.75th observation, right? In other words, the 2.75th row. But we don't have a week or a row 2.75, right? We've just got 1, 2, 3, 4, 5, right? On down to 10. So we have to figure out what to do here. So we have two approaches. Option one is that we can just round up or round down. So we have 2.75 as our rank. So what we need to do is figure out the kind of 2.75th position, if that makes sense. But we can round this up to 3, right? 2.75 rounds up to 3. And so that would give us our closest rank of 3. Well, the 3 means simply 1, 2, 3. If I count down in the ordered numbers, 42, 43, 47. So this gives us 47. So we would say our 25th percentile is 47. Option 2 is a little trickier. We're going to take what we call the weighted mean. Now again, let's make sure we understand. We have 2.75 as our rank, but we don't have a week or observation 2.75. So look at that red square in my data here. What we need to do is we're going to figure out where exactly are we between 43 and 47, but we're going to do it using a weighted method. So in the last option, option 1, we said, okay, we know we're somewhere between 43 and 47, but we're just going to round to 3, which 1, 2, 3, that put us at the 47 number, right? Now what we're going to do is figure out the weighted measure, the weighted mean. How do we do this? We start by finding the difference. Okay, the difference between the third and the second observation, right? Because our number falls in between, right? So 47 minus 43 equals 4. We calculate our difference. Then we're going to weight by the percentile. Remember, we want the 25th percentile. So I'm going to take the difference of 4 multiplied by 0.25. That equals 1, right? And now I'm just going to add that to the lower number. 43 is my lower number. Add the 1 gives me 44. So it turns out that our 25th percentile, when we use this weighted mean measure, gives us 44. Now keep in mind, as I've said, this is more precise with a large sample. But we just did 2 different options for figuring out the 25th percentile. Remember, in both, we have to start by ranking our data, low to high, right? 42, 43, 47, 47. Then I use the equation that I had in yellow, right? So if you don't remember, rewind for just a second. I use that equation, plug in what you know, and it's going to give you the rank. So here I have rank 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because I have 10 observations. You can, in the option 1, round, or in option 2, take the weighted mean. Obviously, the weighted mean is a little harder, but it's a little more precise. Now, a percentile is a measure of location, as we said. It's not a measure of dispersion. So hopefully you're asking, well, then why are we talking about it in this lecture? Well, we have something related. The interquartile range is a measure of dispersion. So while percentile itself is not a measure of dispersion, something related called the interquartile range, well, it's a measure of dispersion. Because with interquartile range, we're describing the distribution of data. The distribution, how is it distributed? When we think about the word quartile, quartile means 1/4 or 25%. So the interquartile range is going to be the difference between 25th and the 75th percentile. In other words, it describes the middle 50% of the observations. So we go in a quartile on each side, leaving us 50% in the middle. So we're looking at the middle 50% of observations. Here's a diagram that will probably help you. So we're going in one quartile from the left, we're going in one quartile from the right, leaving us 25% and 25%, a total of 50% in the middle. Okay? Now, to find this interquartile range, we have to find the 25th percentile. That's the Q1 in our diagram. And we have to find the 75th percentile, Q3. Then we simply take Q3 minus Q1, and that's going to give us our interquartile range. So again, back to our diagram, we need to find Q1, the 25th percentile. We need to find Q3, our 75th percentile. We take Q3 minus Q1, in other words, 75th percentile minus the 25th percentile, leaving us that middle 50%, which we call the interquartile range. Let's do an example. Again, please remember that we have this small sample issue that I told you about. Let's use the weighted mean approach. And again, we only have our 10 observations, but it will still be clean for illustration purposes. Instead of rounding, as we said, we're going to use the weighted mean approach. Now, we've already calculated the 25th percentile, right? We did that just a minute ago, and we got 44, right? We got that rank that was in between 43 and 47, and then we used that weighted method. So there we go. That's going to be our 25th percentile. But now we need to find our 75th percentile. So let's do that, and then we gives us an opportunity to practice one more time. All right, so for the 75th percentile, remember the equation. Rank equals the percentile, 75, divided by 100, multiplied by n plus 1. N plus 1 is 11, right? I have 10 observations plus 1. So we get a rank of 8.25. So again, what do I mean by rank? I'm simply counting down how many rows. So it's going to be between the 8th and the 9th row. But where between? Well, that's when we need to have to use the weighted mean method, right? Remember our first step, we find difference. The difference is 3. How did we get that? 55 minus 52. So basically what we're just trying to do is apportion this difference. I'm going to take the percentile that I'm interested in, 0.75, multiply it by the difference, and I get 2.25. All right, what do I do with that 2.25? I add it to the lower number. So 52 plus 2.25 gives me 54.25. Now, I know that's a little confusing, but let's see if we can just get a little intuition here. Remember, we determined that the 75th percentile was somewhere between 52 and 55, right? And we didn't want to just take the rounding method. We wanted to use this weighted method. We see that there's a difference of 3, and then all we did is multiply that by the 0.75 for our 75th percentile. So basically that helped us decide, is it closer to 52 or is it closer to 55? We're just kind of apportioning this difference, which is simply 3. So again, it is a little confusing, but don't let that bother you. All right, so now we've got Q1, right, 44. We've got Q3, which is 54.25. Remember, this is the 25th and the 75th percentile. Now, we just take Q3 minus Q1, so we're doing that, and we get 10.25. Our interquartile range is 10.25 new clients. So there, we've computed the interquartile range. It's handy. You will see that other people use this. You'll now be able to understand it. Interquartile range is not sensitive to outliers. So we've spent, different lectures talking about, okay, is this going to be influenced by outliers? Yes or no? Well, interquartile range is not sensitive to outliers. Think about it. If you have an outlier, they're going to be in either that first or that fourth quartile, right? They're going to be in those two end 25% boxes. They're not going to influence this calculation because they don't influence Q1 and they don't influence Q3. So this is a good way to report data when some extreme observations exist. Because when people read about this data and you report the interquartile range, they know, oh, okay, well, that's not sensitive to outliers. So Now we've got even more things that we can report about our data. We've talked about two measures of dispersion, range and interquartile range, but there are more.